Hi viewers, in this video we will solve problem that is related to a practical applications, that is a engine cylinder, and it is attached with a fins, circumferential fins attached to this engine cylinder. So let's come to the statement. The engine cylinder of a motorcycle is constructed of 6 aluminum alloy with its thermal conductivity 186 watt per meter Kelvin and is of height h, that is 0.15 meter, and outside diameter is 50 millimeter. Under typical operating conditions, the outer surface of the cylinder is at a temperatures of 500 Kelvin and is exposed to ambient air at 300 Kelvin with a convection coefficients of 50 watt per meter square Kelvin. Annular fins are integrally passed with the cylinder to increase heat transfer to the surrounding. Consider five such fins which are of thickness T 6 millimeters, length L 20 millimeters, and equally spaced. What is the increase in heat transfer due to use of the fins? First of all, I will write the uh, data that is given in the statement. The thermal conductivity of the engine cylinder material, that is 186 watt per meter Kelvin. And the height of the cylinder is given. This is the height of the cylinder, and that is h. I will present it by capital H, 0.15 meter, and then outside diameters is 50 millimeter. So it means the R1, the radius of the cylinder from this center line till its outermost valve, that is 25 millimeters. So R1, that is 25 millimeters, means 10 to the power minus 3 meter. And then R2, this is the R2 from this center line of the cylinder till it's the extreme end of the extended surface fins, that is R2, and it is equal to 0.045 meter or 45 millimeter. Okay, the thickness of the fin is 6 millimeter, that is 6 millimeters means 0.006 meter. And then the base temperatures of the cylinder, so the temperatures of the cylinder here at this point, that is B, and it is 500 Kelvin, and the temperatures of the environment, that is infinity, that is 300 Kelvin. The convection coefficients, that is H, and it is 50 watt per meter square Kelvin. So we need to find the heat transfer, increase in heat transfer due to the use of the fin. So what type of increase in heat transfers that is occurred? This delta Q represent increase in heat transfer due to the use of this fins that is attached to this cylinder of the bike engine. Okay, so the total heat transfer will be equal to the heat transfer by the cylinder, that is Q naught, and heat transfer by the fins attached to the cylinder, that is Q F. Let's say it's equation 1. Now first we need to find the heat transfer only the prime cylinders of the engine. So that is Q naught, and it will be equal to H A naught, surface area of the cylinder, and then temperature, base temperatures, the environment temperatures. So what is the surface area? It's A naught, and it will be equal to, so we are interesting to find the heat transfer by the cylinder only. So look at the radius of the cylinder, that is R1, that is 25 millimeter. So surface area will be equal to 2 pi R1, and then multiply its length. So what is its length? That is 2 pi r1, and then this length of this cylinder is equal to the height h minus what is the thickness, that is t. So how many fins attached to this cylinder, that is 5 in number. So subtract total height, subtract 5 thickness of this fins from the height of the cylinder. So we can say h minus 5. Now put the value, you will get the surface area of the cylinder. So that is 2 pi r1 and then h minus 5. So 2 pi r1, that is 0.025 multiply h, that is 0.15 minus 5 into the thickness of this fins, that is 6 millimeter, 0.006. So after simplifications you will get the surface area of the cylinder without considering the fins. By subtracting the thickness of the fins from the surface area of the cylinder, you will get the surface area of the cylinder without fins considerations. So not we'll get that is 0.01885 meter square. Now put this surface area in these equations to get the heat transfer by the engine cylinder only. So that is Q naught is equal to H. H is 50. Then surface area, that is 0.01885 into the temperature difference, 500 minus 300. So you will get 100. After simplifications you will get the heat transfer the engine cylinder, that is 188.496 watt. Now next is we need to find the heat transfer by the fin. So this is the QF we need to find, and it is equal to efficiency of the fin and the maximum heat transfer that can be transferred by the fins when it is at the best temperatures B. From where you get this equations, it is easy, because efficiency of the fin is equal to, so if you are interested to find this actual heat transfer by the fin, multiply the efficiency of the fin with the maximum heat transfers by the fins when all the fins are at a uniform base temperature. So the maximum heat transfer by the fin is equal to convection heat transfer coefficients, then surface area of the fin, temperature difference Tb minus T infinity. So what is surface area of the fin? That is equal to R to C, correct radius, and it will be equal to R2 plus T half, thickness of the fin half. So what is R2? That is 45 millimeter, so 0.045 plus thickness of the fin, that is 0.006 divided by 2. So you will get the correct radius of the fin, that is 0.048 meter. Now the corrected length of the fin, that is L plus T by 2. So what is L? That is here in this picture you can see that is 20 millimeters. So I can say 0.02 plus 0.006 divided by 2. So you will get that is 0.023 meter. The corrected radius and the corrected length of the fins has been calculated. Now the surface area of the fin is equal to, so Here two surface area of the fin. One is this at the lower side and another is the at the top side. So every fins have two surface area. So I can write here 2 and then I and then minus r1 square. R2C is the corrected radius, the outer surface of the extended surface, that is fin. We just put the values now. So there is 2 pi. What is R2C? That is 0.048 square minus R1 square. That is 0.025 square. So after simplifications, you will get its value. That is 0.01055 meter square. This is the surface area of the fin. Okay, now next just put the surface area in this equation to find the maximum heat transfer by the fin. So Q max, that is equal to H. H is 50, and then surface area, that is 0.01055, and temperature difference, that is obvious, 500 minus 300. So after simplification you will get the maximum heat transfer by the fin, that is, this is the heat transfer by the one fin from the engine cylinder. So we have 5 fins, so we will multiply this with 5, and also the efficiency of the fins. So here we will write multiply with 5 because these are 5 in number. If you look at this equations number 2, we calculated the Q max. Next is to find the efficiency of the fin. So we can find this by this graph. From this graph, first we need to find the x-axis, that is equal to LC, that is 3 by 2 into H divided by K and surface area. First the A value, that is equal to LC multiplied by T. So what is LC? That is 0.023 multiplied by thickness, that is 0.006. So you will get its value after multiplications, that is 1.38 multiplied by 10 to the power. Now put all the values of the corresponding variables in these equations to find the axes of this graph to find the efficiency of the fin. So it is LC, that is 0.15. So the axis of this graph we get in the problem, that is 0.15. So here at the mid we will get 0.25. So here our value will lies in this regions 0.15. So if I look at this 0.15, the corresponding value of the fin efficiency, that will lies almost in the 95 regions. So 95% efficiency of the fin. So here I can say that the efficiency of the fin, that is 95%. From this graph, with the help of this axis first we calculated previously. Okay, so efficiency is now calculated, the Q max is calculated. So just put these values in these equations, that will give you the heat transfer by the fin. The heat transfer by fin is equal to efficiency of the fin multiplied by number of fins that is attached, 5, multiplied by Q max. So what is the efficiency of the fin? That is 0.95, number of fin, that is 5, Q max maximum heat transfer by the fin, that is 105 4 watt. So after multiplications you will get heat transfer by the fin, that is 501 1.1 watt. Total heat transfer from this engine cylinder will be equal to Q naught plus Q of the fin. So Q naught is 188.5 plus 501.1. Adding you will get that is 690 watt. So by adding the fins to the engine cylinder, the heat transfer is increased up to 690 watt. The next is to heat transfer without fin. So it will be equal to H A surface area without fin. So I will denoted the heat transfer without fin, that is QW naught, and its corresponding surface area is AW naught, and it is TB minus T infinity. So it means that we are now interested to find the heat transfer without attaching the fin. So we have only the cylinder and there is no attachment of the fin. So if there is no attachment of the fin, so how much heat transfer can occur? So that is equal to, so the important parameter here is the deciding parameter is the surface area of the cylinder. So that is equal to 2 pi r1 radius of the cylinder into the height of the cylinder h. So this is the surface area of the cylinder without fin concentration. So you will get that is 2 pi r1, that is 0.025 multiplied by height 0.15. So you will get its value, that is 0.0235 meter square. Now heat transfer without fin, that is equal to H AW naught area without fin, and then TB minus T infinity. So H is 50, W naught, that is 0.0235 by. So after simplifications you will get the heat transfer by the cylinder without fin, that is 236 watt. The increase in heat transfer, how much increase in heat transfer is occur by adding the fins. This is the heat transfer without fins. So this is the heat transfer. Look at this value. This is the heat transfer with additions of fin at the cylinders, and this is the heat transfer with no additions of fins. So the increase in heat transfer you will observe by adding the fins at the engine cylinders, that is Q minus Q naught. So the increase in heat transfer is 690 minus 236, and you will got watt. So almost 2.6 times heat transfer is increase in heat transfer occurs by adding the fins to the engine cylinders. So this is very important, increase in heat transfer to prevent the engine seize. So that's why extended surfaces like fins is very important parameters when your concentration is to cool down your prime system. So our engine cylinder is the prime systems. We need to decrease its temperature. So that's why we provide fins over it. So that's why you observe that heat transfer is maximum when there is extended surfaces attached to the engine cylinder. When there is no fins attached, you observe minimum heat transfer is occur. So that's why we can say that by adding the fins is important terms in engineering designs. Thank you so much. If you haven't subscribed my channel, please subscribe for more such videos.